Alright, so this should be our video. We're going to start with 9. If you see here, I've written in the change. It was 2p actually, and I've already shown my thing here where it needs to multiply to negative 15 and add to 2, which is our negative 3 and 5. So let's split up that 2p with p squared minus 3p plus 5p minus 15. So from here, we're going to do our grouping. So taking out with a common, well, you can only take a p out of here. That's the only thing we have common here. So that's p minus 3 plus, then we can take out a 5 out of here, leaving us p minus 3. So again, we are left with the same thing here, leaving us p minus 3 times p plus 5. Alright, number 10. It's the same thing. I'm just going to show you how I would factor this one out. They all have a common term already, so we can already take out a 3 here, which might make it a little easier to see what we need. So we have p squared minus 2p minus 8. So we can kind of do that x method here I kind of do. So it needs to, we're going to focus on this part. So 1 times negative 8. Negative 8 needs to add to negative 2. Well, what two factors can do that? Well, negative 4 plus 2 gets us negative 2, and when you multiply, you get negative 8. So we're going to split those up. So we're splitting those up here. Plus 2p minus 4p minus 8. So what we can take out of here, right, it's just a p, so then we're left with p plus 2. And then we're going to take out a negative 4 here, right, so leaving us with a p plus 2. Then we're left with 3 times our p plus 2 times our p minus 4, which is what we were left with here. Alright, number 11, right, as a product of prime polynomials. So I saw this as take out what they have in common first. So we're going to take out a 3, leaving us a 9, p squared minus 12p plus 4. So this is going to be that formula where we need to see that it's 3 squared and 2 squared, and then 3 times 2 times 2. If you remember that, I think it's, I can't remember the exact thing, but it's that 2ab a squared plus b squared. So yeah, this is getting you 9, and this is getting you 4. And by doing this, you're going to get 12. So that's what you're seeing here. So then we're left with a 3, again, keeping that in mind. Then we can make that the a minus b. Or a plus b, sorry. No. It's a minus because it's a negative 12. Sorry about that. So it's a minus b. So then we're left with our 3p minus 2 squared. Hopefully that makes sense. But it's only different because of that 3 we pulled out there. So number 12, simplify. So this is wanting us to use non-negative values, which there's no negative here. So basically they were wanting you to see that z, the square root of z to the 16th, you're wanting to do, basically is going to be z, you can do the z 16 times and seeing the pairs, but I'm going to kind of just show you a way that I did. It's kind of just quicker, because you know that the square root of z is actually z to the half, right? Because that halving is equal to the square roots, right? So what we're doing here is actually z to the 16th is being risen to the half. exponent. And what do you do when exponents have exponents? We multiply them, right? So 16 times 1/2, which is basically just dividing it by 2, is 8. So then we're left with z to the 8th. Alright, number 13. For the given function, find the indicated function value. If it does not exist, write does not exist. So for this one, we are going to try to figure out if it's possible, right? So we're going to plug in -3 wherever we see an x here. So we're going to be left with -3 squared minus 15. Now, -3 times -3 is a positive 9. And then we're left with minus 15. Now, this gets us a -6, right? Which is not possible. So it does not exist. Alright, number 14, we're going to find out if it exists or not. So again, we're going to plug in -4. So keeping track of that negative there. 2 times -4 plus 1. Make sure we're keeping track of these parentheses, right? So plugging that in, we're going to simplify here. So -4 times 2 is a -8. If you're adding a 1 to that, it's going to be -7, right? So we're having negative with a -7 squared. So let's simplify that even further, right? -7 times -7 is a positive 49. Well, the square root of 49 is 7, right? So this will give us a negative of, I guess it could be plus or negative positive 7, but it's a positive 49 here. So this is kind of what you want to have here. Alright, number 15. We're going to simplify this cube root. Gotta be honest, you could just put this in a calculator. You should be getting -16, because -16 to the third is -16 times -16 times -16. Number 16, simplify the same thing here, but now we have a variable. So this is where we're going to do that method. Again, you're just going to you can plug this in a calculator of this, of 2,401. That's actually just 7. So keeping that in mind, we're just going to pull out a 7 here. But we're still left with that x to the 8th. So, think about it. This is actually x being written 8 times, right? How many times does 4 x's show up? How many groups of 4? 2, right? So, what you're basically going to be pulling out here is just an x to the x squared. Because x squared to the 4th gives us our x to the 8th. And that's all you're kind of wanting to do there. Alright, number 17. Oh, sorry, that's going to be with the absolute values there. Number 17, write an equivalent expression using radical notation. So again, they're wanting you to use the roots. So, like I said, remember if x to the half is the square root of x, basically, this just equals the 7th root. I don't know exactly how you're supposed to say that one, but yeah. Number 18, rewrite using exponential notation. So basically, we're going to be doing, again, keeping the same method here. This is actually being risen to the 6th, which is basically x to the 7th over 6th. Alright, so that is where we're going to end here, and then we are going to have the final part in the third video.